So, hello, my name is Ritraj and I'm from CSE Department A section for the fifth semester. My topic is Introduction to the Types of Engineering Research, Finding and Solving a Worthwhile. So, Introduction to Engineering Research. Engineering research is a systematic and methodical process aimed at solving problems, advancing knowledge, and developing innovative solutions in the field of engineering. It combines scientific principles, creativity, and technology to address real-world challenges. Engineering research can span various disciplines such as civil, mechanical, electrical, computer, biomedical, and environmental engineering. So the purpose of engineering research is to problem solving, developing a solution for technical, societal, or environmental issues. Innovation, create new technologies, processes, or materials. Optimization, enhancing the efficiency, performance, or sustainability of existing system. Knowledge expansion, contributing to the understanding of fundamental principles and theories. Commercialization, developing marketable products and technologies. Key components of engineering research. Problem definition, clearly identify the issue or challenge to address. It is a reviewing existing work to understand the current state of knowledge. Research methodology, developing a systematic approach to investigate the problem. Data collection and analysis, gathering and interpreting data to draw meaningful conclusions. Implementation of data, testing, developing prototypes or solutions and testing their effectiveness. Documentation and dissemination, writing research papers, patents, or technical reports to share findings. So, types of engineering research. Engineering research can be classified into several types based on subjective methods and application areas. Below are the key types. Theoretical research definition focus on developing and refining mathematical models, simulations, and theories to predict behaviors, understand phenomena, or explain principles. For example, formulating equations. Um, okay, so characteristics of a worthwhile problems. So worthwhile problems are those that are meaningful, impactful, and worthy of investment in time and resources. Below are the key characteristics that define such problems, especially in research and engineering context. Relevance. The problem addresses a significant need or challenge in society, industry, or specific field. Aligns with current priorities such as sustainability, innovation, and public health. Example, developing renewable energy systems to combat climate change. The next is novelty. The problem is unique or introduces a new perspective to an existing challenge. Contributes to advancing knowledge or technology. Example, exploring the use of nanotechnology for drug delivery system. Feasibility. The problem is solvable within the constraints of available resources, time, and expertise. It has a clear path for investigation and potential conclusions and solutions. Example, designing a cost-effective water filtration system for rural communities. Next is the impact. The problem has the potential to create significant positive change. It benefits a large population, improves quality of life, or enhances efficiency. Example, developing accessible assistive technologies for people with disabilities. By clarity and specificity, the problem is clearly defined with measurable objectives and outcomes. Ambiguity is minimized to ensure focused research or development. Example, reducing energy consumption in HVAC system by 20% through innovative design. Interdisciplinary potential. So the problem allows collaboration across multiple fields or disciplines. It opens opportunities for diverse expertise to converge. Example, combining artificial intelligence and biomedical engineering to improve disease diagnostics. Scalability. The problem and the solution can be applied or adapted to a broader context. It supports future growth and innovation. For example, creating modular housing units for rapid deployment in disaster zones. Next is ethical considerations. Uh, the problem and its solution align with ethical principles and societal values. They avoid harm and promote equity in inclusivity. For example, ensuring fairness in AI algorithm using hiring process. Nine is economic viability. The problem has potential for economic benefits such as reducing costs, or creating new markets. It appeals to stakeholders and vendors due to its financial sustainability. Example, developing a low-cost alternative to lithium-ion batteries. Opportunity for learning and growth. The problem offers a chance to gain new insights, skills, or knowledge. Challenges researchers and engineers to think creatively and critically. Example, investigating untested materials for use in extreme environmental conditions. Um, Worthwhile problem is not only significant but also actionable with the potential to contribute uh, meaningfully to both theoretical and advancements in practical applications. Um, Finding a research problem. Finding a research problem involves identifying a research problem is a crucial first step in conducting meaningful and impactful research. Below are strategies and steps to help you find suitable research problems, particularly in engineering related fields. Understanding your interests and expertise. Uh, Explore personal interests, identify areas within your field that excite you or align with your passion. Leverage existing knowledge, consider topics where you already have expertise or prior experience. Assess career goals, focusing on problems that align with your long-term academic professional objectives. Next is conduct a comprehensive literature review, explore current research, study recent publications, journals, and conferences proceedings to identify gaps or unresolved questions. So analyze the trends to look for emerging topics, technologies, or challenges that are gaining attention. Next thing, identifying controversies. Pay attention to debates or conflicting findings that require further investigation. The next is focus on real-world challenges. Observe practical problems, investigate issues faced by industries, communities, or society at large, engage with partners, collaborate with professionals to uncover problems in need of innovative solutions, then align with global needs, address challenges related to sustainability, healthcare, energy, or technology, brainstorm with others, collaborate with peers, discuss ideas with colleagues, mentors, or research groups, participate in workshops, attend seminars, webinars, and hackathons to gain fresh perspectives, engage with interdisciplinary teams, broaden your scope by exploring problems at the intersection of multiple disciplines, analyze the gap between theory and practice. So, identify technologies, theories, or methods that work in theory but face challenges in practical implementation. For example, adapting laboratory developed materials for large scale industrial use. Examine technological advances. Leverage new tools. Explore how recent technologies advancement can be applied to solve missing system. Use big data, AI, or IoT to address issues in new and efficient ways, which results in innovating the data. So utilize the research tools and resources. Search databases used like platform IEEE, Explore, Scopus, or Google Scholar to find trending topics. Analyze the patents, review patents to identify technologies that benefit from the improvement or adaptation. Track finding funding opportunities. Look into grantings or funding calls to identify areas with high demand for solutions. Narrow down your topic. Ensure the problem is specific, measurable, and actionable. Avoid overly broad or vague topics to maintain focus. The next is, for example, instead of improvising transportation system, consider optimizing energy efficiency in electric vehicles using AI algorithms. So next is considerable feasibility. Assess where the problem can be tackled within the available time, budget, and resources. Ensure you have access to tools, data, and expertise required to address the problem. Next is evaluate the impact. Choose problem with the potential to make a significant contribution to the field of society. Prioritize topics that address global challenges or benefit underserved communities. Uh, by following these steps, you will systematically identify a research problem that is both worthwhile and achievable, ensuring a strong foundation for your research journey. Solving the research problem. So, solving the research problem involves a structured and systematic approach um, to finding effective solutions or answers. Um, so, first step is define the problem clearly. Understand the scope, clearly articulate the research problem, its background, and its significance. Set objectives, identify the specific goals you aim to achieve, develop precise research questions or hypotheses to guide your investigation. The next step is conduct a thorough literature survey or review. Study existing research to understand the current state of the knowledge, highlight areas. where existing solutions are inadequate or non-existent. Analyze methods and approaches used in similar studies. Next step is develop a research plan. Decide on qualitative, quantitative, or mixed methods based on the nature of the problem. Outline steps, break the problems into smaller manageable tasks. Set a timeline, establish deadlines for completing each stage of the research. Next, collect the data. Use primary data, experiments or surveys, or secondary data like existing data sets and literatures. Collect data systematically, minimizing errors or biases. Employ software equipments or instruments suitable for your research. Use statistical computations or qualitative techniques to examine the data. Cross-check findings with theoretical models of previous studies. Relate the results to your research questions or hypotheses. Next step is develop solution. Um, First, generate multiple solutions based on your findings. Use prototypes, simulations, or models to evaluate feasibility and effectiveness. Um, then refine the solution to maximize efficiency, reliability, and applicability. Um, what is next? Next, validate your solution. Conduct experiments to confirm the validity of the solution. Present findings to peers or experts for constructive feedback. Implement the solution in the practical settings to assess its impact. Next is communicate findings or write research papers, technical reports, or patents to present your work. Share your findings through conferences, seminars, or workshops. Submit your works to journals or platforms for wider dissemination. Next is reflect and iterate. Assess whether the solution fully addresses the problem. Consider areas for further refinement or additional research. Reflect on challenges and successes to improve further future research efforts. Next is implement and monitor. Uh, Deploy the solution, apply the research findings or solutions in real world scenarios, track performances and gather feedback to ensure long-term effectiveness. Expand or modify the solution to address similar problems in different contexts. By following these steps, you can approach research problem systematically, ensuring robust and meaningful solution. Tools and techniques in engineering research. So, engineering research requires a variety of tools and techniques to design, analyze, test, and optimize solutions. Below is a comprehensive list of tools and techniques commonly used in engineering research. Literature review tools to review existing knowledge, identify gaps, and understand the research context. For example, Google Scholar, IEEE Expose, Scopus, and many more. Next is design and modeling tools. The purpose of this is to create, analyze, and simulate designs and systems. For example, CAD software, MATLAB, ANSYS, COMSOL, or StatPro. The next is data collection tools. The purpose is to gather quantitative and qualitative data for experiments or fieldworks. Examples are sensors and IoT devices, survey platforms, and data loggers. Data analysis and statistical tools. The purpose is to process and analyze research data for the pattern trends and insights. Next is computational tools. Computational tools is used to solve complex mathematical problems and run simulations. Next is experimental tools and equipments. The purpose is to conduct experiments and validate theories on designs. Machine learning and artificial intelligence tools. Purpose is to analyze large data sets and develop intelligent models. Okay. The next is challenges in engineering research. Challenges in engineering research is essential for advancing technology and solving real-world problems, but it's not with its challenge. These obstacles can rise from technical, financial, societal, and ethical considerations. Below are some of the key challenges faced by researchers in engineering. Identifying the research problems, resource constraints, data-related changes, rapid technology advancements, interdisciplinary collaborations, experimental simulation challenges, ethical and societal issues, dissemination and application of research, multiple disciplinary and global challenges, personal challenges for researchers, strategies to overcome challenges are collaboration, build diverse interdisciplinary teams to pool resources and expertise, networking, engage with academic industry and funding bodies to access support, training, stay updated with the continuously learning and professional development, efficient planning, use project management tools to organize research effectively, promote the importance of research to stakeholders, policymakers, and public. Engineering research requires a perseverance, adaptability, and strategic thinking to overcome these challenges and contribute to meaningful advancements. Some case studies are development of self-driving cars. The problem was traffic safety and efficiency. The solution they found out was integration of AI and sensor technologies. Next is renewable energy systems, reducing carbon emissions, innovations in solar and wind energy technologies. The conclusion is engineering research encompasses fundamental applied, experimental, and developmental tools in identifying and solving a worthwhile problems. Requires relevant feasibility and impact assessment. So, collaborative, innovative, and ethical approaches ensure successful outcomes. Call to action: innovate, collaborate, and drive the future of engineering. Thank you.